Hello, dear students. Very good evening to all of you guys, and welcome back to a new session of your 500 plus MCQ. Right? So, guys, in this particular session, basically, we will discuss the 15 question of your structure analysis part, which will be very important for your GATE and ESE examination. And the total number of question in this session is basically 30, right? So out of them, 15 we will discuss in the class, and the rest of the 15 question I will give you as a homework, which you have to solve by yourself. Okay, but you will get the solution of these question guys in my telegram. Okay, so later on I will explain where you will get exactly this particular pdf and where you will get the solution of these questions. Okay, so let's start the session guys. Let's start the session, and this is my first session on this particular channel. So let's understand guys the various type of question of structure part. Okay, very good evening to all of you once again. So those who are new over here and those who don't know about my profile, let me tell you about myself. My name is Krishna Yadav and I'm teaching from last 9 years guys, and I have done my masters from IIT Roorkee, and generally I will take the environment engineering, structure, RC and mechanics part for GATE examination as well as ESE examination. So guys, let me tell you some very important information which will be very helpful for your upcoming GATE examination. As you know that guys, in the last duration we need to revise all the formula, all the concepts and the question part at the same time. That is the general procedure which we have to do. So guys, it will be more easy when you will revise all the things with from faculty. So from 3rd of Jan we are starting basically Maha Marathon session, which is non-stop Maha Marathon. So on a daily basis you will get a marathon session guys, right? Like 8-hour session in which you are able to cover the all the formula, all the topics as well as the question part in a single shot. So that's why guys, if you want to join this particular session, you have to be live on from 3rd of Jan, right? So don't forget to subscribe our channel and subscribe it, right? Okay, so guys, there are two mega workshop which you can join. One is on 1st of Jan, right? And the second one is on 27th of December. So you can join it, right? Okay, guys. So let's start our question number one. Let's start our question number one. This is our question number one, guys, which is basically based upon the kinematic indeterminacy. You need to tell me how many sway component, not total kinematic indeterminacy. You have to just tell me how many sway component are there in this particular structure, right? Which you have to consider as a kinematic indeterminacy part, right? Tell me guys. Let me hide myself so that you can see this particular question properly. Okay, now tell me guys, how many sway components are there in the structure, right? So that you can find out the kinematic indeterminacy. Tell me guys, how many sway components are there in the structure? Very simple question, very simple question. Tell me. Guys, as you know that in this particular structure, 4. Very nice, Akarsh. Very nice, very nice. Yes, definitely it should be 4. You know that guys, in this particular direction, one of the component can be possible. That means this is basically delta 1. Similarly, this one is also there. That means basically delta 2, which can also be possible. In this direction, we will have the sway. For this particular portal and for this particular portal, the sway component will be different. Similarly, in this particular direction, we will have another sway component and this one also, right? So this one is what? This is basically delta 3 and this one is delta 4. So total 4 component of sway will be there guys in this particular structure. That's why A is the correct answer for the given problem. Crystal clear to all of you guys? It is crystal clear to all of you? Sabhi ko samajh mein aa gaya, right? Very nice. Let's move to the next question. Now in this particular problem, you need to find out the kinematic indeterminacy for the given structure, right? And this problem is very different. Why it is different? Because this is a 3D truss in which you need to understand how many joints are there and how many supports are there by using the elevation and the plan of the structure, right? That's why it is very different type of question. So let's understand guys, how many of you are able to solve it. Kindly see this particular structure. What is given to us? This is basically a elevation. This one is elevation. And what is this? This is basically plan. Now we need to find out how many joints are there and how many supports are there so that we can find out the value of dk in case of 3D truss. So tell me guys, what is the formula to find out the dk value? Can I say that it is basically 3j minus re? Right? Now the question is, sir, how many joints are there and how many support reactions are there? How we can count it? So let's see guys. In this particular case, at this particular support, or you can say that at this particular joint, there are basically 3 support, right? 1, 2, 3, right? So if you want to count how many support and how many joints are there, you need the basic plan of the structure, right? So you can see here guys, this is basically DHI. At DHI, we will have the support. So this is D, this is H, and this is I. Similarly, we will have EFG. So this one is E, F, and G. So that means how many supports we have? Total 6 supports. Total 6 number of supports are there. Getting a point? Now the question is, sir, how many joints are there? How many joints are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So total number of joint is 9. And let's calculate the total number of reaction. It is basically, there are 6 support, but each and every support will have 3 reaction because it is a 3D hinge support. This one is what? 3D hinge guys, 3D hinge. That is the reason, right? Very nice. DK is equal to 21. Okay, Akash. So this one is equal to how much? 18. So let's calculate this one value. So 3 into 9 minus 18. How much it is? 9. 3 into 9 minus 18. 27 minus 18 reactions. So total number of joint displacement which can be possible, it is equal to 9, Akash. It is not 21. Are you getting a point? All of you. Tell me guys. The value of dk is not 21. It is basically 9. Getting a point? Crystal clear to all of you guys how to solve such type of question, because it is a different kind of question in which we have the plan as well as the elevation of the structure. That's why. Okay. Clear? Let's move to the next question. Now again guys, in this particular problem, we need to find out the dk value. But you need to give focus over the reaction release concept as well as the support which we have, right? Okay, so let's understand the question guys again. Let's understand the question. So we need to find out the kinematic indeterminacy of the given structure. Now let's understand guys how we can solve it. So at this particular support, how many reaction can be possible? 2. At this support, it should be 3. At this support, it should be 3. This is horizontal guided roller support. That's why 2 reaction can be possible. And this is a roller support. 1 reaction is possible. And this is basically a smooth surface and a free end is placed on the smooth surface. That's why 1 reaction is possible. So let's calculate how many total reactions are there. Just count it. 3 plus 3, 6, 6 plus 2, 8, 8 plus 1, 9, 9, 1, 10 and 12. 12 reactions are there. And let's count how many joints are there in the structure. How many joints are there? 1, 2, let me mark it with marker. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So total number of joint is 8. Okay. So what is our formula? Basic formula. dk is equal to 3j minus re minus nr plus rr. What is j? J is number of joint. Re total number of reaction. Nr is number of member which are axially inextensible. And rr means the total number of reaction release. So you can see here guys, we have some hybrid joint also. This is basically our hybrid joint at which some reaction will be released, and that reaction release is equal to how much? How many members we have at this particular joint? 1, 2, 3, 4. 4 minus 1. So the number of reaction release is 3. 3 into j. Joint is 8. Re is equal to how much? Re is equal to 12. Nr is equal to how much? Right now we don't have to consider Nr. Okay. We'll check the option first. And Rr is equal to how much? It is 3. Why we are not considering Nr? Because it is not given in this question also. Okay. That's why you don't have to consider it. But guys, let us suppose if you are not able to get any option which is matching with your solution part. So kindly check whether they have considered the member is to be actually inextensible or extensible, right? That you have to check, right? Otherwise, usually they will try to write it down. The members are actually inextensible. Okay, let's count it, how much it is. So 3 into 8 minus 12 plus 3. So this value is coming around 15. That means we got one option which is basically 15, and that is our correct answer. Clear? Very nice, Akash. Very nice. Let's move to the next question. Next question in front of you. Very easy question. Just you have to give the direct answer. If you know the logic, you are able to give the answer directly. Okay. Tell me guys quickly, what should be the answer for this question? Akarsh, Rishabh, tell me guys, what should be the answer for this particular problem? A prompt cantilever is there, AB, whose length is L, and it is subjected to a point load P, which is placed at point A, right? And then what will be the bending moment at support B? That is the question. Tell me guys, it is very easy question. 0. Arey Baba, it is 0. It should be 0. It should be 0. Why it is 0? Because you know that guys, the load is acting at the support itself, right? So there should not be any kind of movement which can be developed at this particular support. Are you getting a point? Why? Because this particular P value will be equal to VA directly. This VA value will be equal to P itself. That particular load will get completely transferred with this particular support reaction. And that's why guys, if you take the summation of moment at joint B is equal to 0, you will able to get the answer. That means MB is equal to 0, right? That's why C is the correct answer. Yes, Satish. Yes, Wali. Yes, Akash. Next question. Next question, guys. Very nice, Rishabh. Next question. Let me hide myself so that you can see the figure properly. Okay. So what is given to us? There are basically three members: AB, BC, and BD. Okay. AB, BC, and BD. These are the three members which is connected at joint B. Now support C and support D are hinged. A is fixed. Now the member AB has a length of L. This length is L. And the member BC is having a length of 1.5 L. And the member BD is having 2.5 L. Okay. EI is constant in the complete structure. Now what should be the distribution factor of member BA at B? You need to find out what is the distribution factor of member BA at B. Please find out the distribution factor for BA. Distribution factor for BA. How much it is? So guys, it is very simple. You need to find out the stiffness of individual member, correct? So what is the stiffness for BA member? The far end is fixed. So what should be the value? 4EI by L. Okay. Good evening, Swapnil. How are you? कैसे हो बच्चे आप? Then KBC is equal to, the far end is hinge. So we have to write 3EI by L. L is 1.5 L. Then KBD, again 3EI by L. 3EI by L, L is 2.5 L. Now guys, just you have to take the summation of all the stiffness to get the value of summation K. Clear? So 4 plus 3 divided by 1.5 plus 3 divided by 2.5. So this value is basically 7.2 times of EI by L. Correct? Now let's find out the distribution factor. Distribution factor for BA is equal to KBA divided by summation K. Let's do it. 4EI by L divided by 7.2 times of EI by L. Please do this calculation. How much we are getting? 0.56. Very nice, Rishabh Pant. 0.56. Very nice. So A is the correct answer. Prashant, very nice. Very nice, Swapnil. Very good, guys. Very good. Keep it up. Very nice, Akash. Very nice. Superb. So all of you are getting the correct answer. That means A is the correct answer for the given problem. Now let's move to the next question. Let's move to the next question, which is based upon slope deflection method, right? Slope deflection method. Let me come back. Slope deflection method. This problem is related to slope deflection method. If you use SDM method, then this problem will become very easy. If you use any other method, guys, it will be a lengthy one, right? So do it and let me know the correct answer for the question. You just need to find out the slope which is formed at joint B or at support B. Quickly do it and let me know the correct answer for the question. थैंक यू राजपूत, थैंक यू सो मच। अच्छा लगा कि मेरी कुछ मेहनत किसी बच्चे के काम आई, तो मुझे बहुत अच्छा लगता है कि कोई बच्चा अगर उसे कुछ आउटपुट निकाल लेता है तो हमें इस चीज से ज्यादा कुछ नहीं चाहिए, राइट। थैंक यू सो मच फॉर योर फीडबैक, अच्छा लगा आपसे ये सुन के। राइट आकाश, आकाश सी, ओके 133.33 divided by EI, that means C. Okay, we will see which particular option can be correct. Guys, just you know that how to write down the slope deflection equation or slope deflection equation basically for this particular structure. So before writing it, we need to find out the fixed end moment. Okay, so let's find it out. MAB bar and MBA bar. MAB bar, how much it is? It is basically minus WL square divided by 12. How much it is? Minus 25 multiplied by 8 square divided by 12. So let's calculate how much it is exactly. 25 into 8 square divided by 12 bacha. So this value is basically minus 133.33 kilonewton meter. Clear? Now similarly we will have BA bar value also, but that value should be positive, right? Why it is positive? Because it is clockwise in nature. That is the reason. So plus WL square divided by 12. So this value will be same, but we will have just opposite sign. Kilonewton meter. Now you know that, guys, how we can write down the equation at support B, right? So let's write it down. MBA bar is equal to, or sorry, we need to write slope deflection equation. So MBA bar plus 2EI by L bracket 2 theta B plus theta A minus 3 delta by L. Correct? This is the equation. We know that, guys, the value of MBA is equal to 0. The final moment at support B is equal to 0. What is the value of BA bar? The BA bar is plus 133.33 plus 2 EI by L. What is the value of length? It is 8 meter. Then multiply by 2 theta B. What is the value of theta A? We know that theta A is 0. What about the settlement of support? There is no settlement. So again, this value will be 0. Correct? Let's calculate the value of theta B. So theta B will be equal to minus 133.33 multiplied by 8 and divided by 4 EI. Please calculate this, you will get your answer. 133.33 multiplied by 8 and divided by 4. So how much we are getting, guys? Minus 266.66 divided by EI. Now tell me which option is correct. Which option is correct? A is the correct answer. Minus 266.66 divided by EI. That is the correct answer for the question. Swapnil, very nice. Akash, very nice. Now I think you are able to understand how to solve such type of question, correct? Very nice. Let's move to the next question. Question number 7. Suppose a moment is there whose value is equal to 2000 kilonewton per meter and which is applied at joint A. That means we have a moment at joint A and that is equal to 2000 kilonewton per meter. Now we need to find out what is the value of MAB. That means, you know that, guys, how to calculate the distribution factor. So just you have to calculate the distribution factor, and according to that you need to find out the moment in member AB at support, means at joint A. Clear? Let's do it. So first we will find out the distribution factor. So to find out distribution factor, you need to find out the stiffness of the member. So KAB, again far and fix, far and fix, far and fix, 4 EI by L. But be careful, the value of EI is different, right? It is different. So 4 into 4 are EI divided by L. That means it is 16 EI by L, bacha, right? Now next value is KAC. Now in this case, they have used 5 EI, right? So 4 into 5 EI divided by L. So this value will be 20 EI by L. Okay. Next value is KAD, which is equal to 4 EI by L. Okay. Now let's add all the value to get the summation K value. Summation K. Summation K. Okay, Rishabh, 800. We will check it out. So total is 16 plus 20 plus 4. It is 40. 40 EI by L. 40 EI by L. Now guys, we'll write down the moment in AB. AB is equal to KAB divided by summation K multiplied by 2000. So KAB is equal to how much? KAB is equal to 16 EI divided by L divided by 40 EI divided by L and multiply by 2000. So just calculate this value, you will get the answer. 16 into 2000 divided by 40. So 800, I think, very nice guys, very nice. It is coming around 800 kilonewton meter, and that is our correct answer. It is kilonewton meter, not kilonewton per meter. Clear? Right. Rishabh, Akarsh, Prashant, Swapnil, all are you correct. Sabhi se sabhi sahi hai. Okay. Now next question. Now this particular problem is related to the logic part, not the numerical question. This is a logical question, right? So you need to tell me guys, at joint B, the slope of ILD is trying to change. Now which type of joint it can be? That is the question. Now this is a logical type of question, not a numerical one, right? So tell me the correct answer for this. A logical question in front of you. Tell me guys. It is an internal hinge, it is a pin support, or it are A or B both, or none of this. That is the question. And this particular problem will tell you a short trick also guys to solve the question of ILD. Later on we will solve it, right? Later on we will solve one problem which is related to this concept. Yatish A, Prashant C. I will tell you, right? We'll solve a question which is related to this, okay? Prashant C, Yatish A. Swapnil D, Akash C. Guys, the correct answer is internal hinge. A is the correct answer. It is internal hinge basically. Please remember this particular point. It's very important. Please remember this particular point. The slope of ILD will always change at a point where an internal hinge is there. Not a pin support, not a roller support. Now the question is why, sir? Why it is so? So let's understand with one example, okay, so that you can feel it also. Okay, let us suppose this is the internal hinge, right? And I need to find out the ILD of this particular vertical reaction. So as per Mueller-Breslau law principle, you need to release the reaction and ultimately give a unit displacement in the direction of reaction itself. So the deflected shape of the structure will give us the ILD. Correct? That is the concept. So I will give the unit displacement, that means delta is equal to 1. Now if you give the delta is equal to 1, the slope of the ILD will change at this particular point like this. Now tell me, the slope of this particular portion is different and the slope of this particular member is different. Yes or no? Tell me guys. The slope is different for this particular portion and for this particular portion. Why it is changing? Because this is a hinge. This is a hinge. At the hinge, the slope will always get changed. It will always change. Getting a point? But why it is not changing at the pin support or at the internal hinge? Let me tell you. The reason is this particular member is a continuous member, right? It will not break at any junction or at any point in between it, right? In between these 2 points, it will not break. That's why guys, if you give any type of means in any direction if you give the unit displacement, right? So this particular member will have a continuous slope. The slope of this particular portion will not change anywhere. That is the logic, right? Because it is a continuous member, right? It is placed like this. It is placed like this. Are you getting a point? So the member will have same slope. If this particular portion will bend in this way, so similarly this particular portion will have the same slope value. Getting a point? Now I will tell you one question, right, which is related to this concept, and we'll get the answer. It is clear to all of you? By using this trick, we are able to solve a lot of question of ILD. Kindly apply it, right? Kindly apply it. Let me tell you one simple question, then we'll discuss the rest of the question also. Okay, let me bring that particular question first. Okay, kindly see this particular problem, right? We'll come back to that, means our question number, what is that question exactly? We'll come back to this particular question number 9, right? Okay, after this, but let's solve this particular question first. Okay, kindly see this. Now guys, right now, listen carefully. Right now, don't read the question. I'm telling you a short trick, right? Don't read the question, because you are able to see the option and you know that this is the question which is related to the ILD. Yes or no? Yes. Now this particular structure is given to us, correct? Okay. Now kindly mark the hinge first. E is hinge and F is hinge. So it is understood, if you want to draw any ILD for any stress function, whether it is shear force, whether it's bending moment, whether it's reaction part, the slope of ILD will always change at point E and at point F. Why? Because we have internal hinge. Now kindly observe in which option this particular criteria is satisfied. If you get the option, then you get the answer. Let's see. Tell me guys, in this case at E and at F, the slope is same, it is continuous, it is not possible. This one again, slope is continuous, it is not possible. This is not possible, it is continuous, and D is the correct answer. Why? At this point the slope is changed, at this point the slope is changed. Kindly see it. This particular portion will have different slope, this portion is different slope, this portion is different slope. So D is the answer. Now tell me guys, without reading the question, by applying the logic, can we solve the question? Yes. Even in the GATE examination or in ESE examination, you can do it. Now tell me guys, all of you are able to understand? Tell me yes or no. Very nice, very nice. Let's come back to the question number 8, right? Kindly use this particular trick while solving the question, okay? The next question guys, next question. There are two wheels, 80 and 200, and the spacing between these two loads are 2 meters. Okay, right now we don't know which one is leading. Okay, right now we don't know which one is leading. Let us consider it is 80 kilonewton and this one is 200 kilonewton. Okay, no problem. Now a simply supported girder of span 9 meter. Okay, the spacing between these two loads is 2 meter. A simply supported beam is there. A simply supported beam is there whose span is basically 9 meter. So this is basically 9 meter. Now we need to find out the maximum positive and negative shear force at a section of 3 meter. That means from the left end. So this is our left end. From the left end, I need to mark a section at a distance of 3 meter first. And this particular distance will be 6 meter, correct? So let's mark it. This is 3 meter and this one is 6 meter. So at this particular section, I need to draw the ILD first. Okay. Now, what is written over here? We need to find out maximum positive and maximum negative shear force, right? Now, as well as they have written, any wheel load can lead the other. That means it may be possible 80 will be leading or 200 may be leading, right? It is up to you which particular load you have to consider. Okay, let's understand. So first we will draw the ILD at section C for shear force. So you know that guys, what is the procedure to draw it? Use Mueller-Breslau law principle. Kindly break it. Left portion should move downward and right portion is upward. Right? So this will be our ILD. This will be our ILD. This is negative. This is positive. What is this ordinate? A by L. And this ordinate is B by L. So what is the value of A by L? A is equal to how much? 3 meter. 3 divided by 9. And this value will be 6 divided by 9. Now guys, we have two loads. One is 80 and second is 200. Now it is up to you which particular load you will consider as a leading load. That is up to you, right? But the spacing between these two loads is 2 meter. Now tell me guys, first I wish to find the positive shear force. The positive shear force should be maximum. Now tell me guys, what I will consider? I will consider the 200 kilonewton load should be placed at the maximum positive shear force ordinate, right? As well as the 80 kilonewton load should be present on the positive ordinate itself. So this can be the condition, right? In which 80 can be leading and 200 is following. We'll consider this. Why? Because if you put 200 at this particular point, then 80 will be in further. You can say that in the forward direction, right? But let us suppose if you consider this situation in which 200 is leading and 80 is behind. So tell me guys, if you put 200 at the maximum ordinate, then 80 will be on negative side, which will not give our maximum positive shear force value. That is the reason, right? So kindly remove it and consider this particular case to find out the maximum positive shear force. Let me tell you one more trick to get the ordinate quickly. Okay, do you want to learn? Tell me guys, maximum positive shear force. Do you want to learn this particular trick to get the ordinate quickly? Tell me yes or no. Please write down first, then only I will tell you. मेरे पास बहुत खजाना है ट्रिक्स का. Okay, listen. Tell me guys, what is this ordinate? 6 by 9? 6 by 9? Now listen carefully. By how much distance you have to shift in this particular direction? 2 meter? Correct? 2 meter. By 2 meter, I want to shift in this particular direction. Why? So that I will get the ordinate, which is this one. Because 80 will be present at this particular location and 200 will be present at this particular location. Now the question is, sir, how I can get this particular value of ordinate? That is the question. So listen guys, what you have to do, please write down the denominator value as it is. As it is. It is 9, it is also 9. Now by how much distance you are trying to shift? 2 meter. Kindly subtract it from the numerator part. That means 6 minus 2. It will become 4. And this is your ordinate. Getting a point? Easy or not? Easy or not? So this is basically 200 kilonewton and this is 80 kilonewton. Now calculate the value. You will get the answer. 200 multiplied by 6 by 9 plus 80 multiplied by 4 by 9. Please calculate this value. How much it is? 200 into 6 divided by 9 plus 80 into 4 divided by 9. So guys, the first value which we are getting is 168, I think. Kindly check it. 168.88 kilonewton as a positive. Are you getting this value? 168.88 kilonewton as a positive value. Clear? Clear? Okay. Now similarly guys, we need to solve the second condition. For negative shear force, for maximum negative shear force, what should be the location of loads? Again, you need to draw the same ILD which you have. This is positive, this is negative, and this value is 3 by 9 and this one is 6 by 9. Now tell me guys, what is my requirement? My requirement will be both the load should be present on the negative side. Then only I will get the maximum negative shear force. Correct? This distance is 3 meter. We already know that. And this distance is 6 meter. Now in this particular case, what I will consider, my 200 kilonewton load is leading basically. you can change it, right? Because it is written in the question. I will consider 200 kilonewton load is leading and 80 is following. So what I need to write, guys, 80 should be present at this particular maximum negative ordinate, and sorry, 200 will be present at the maximum negative ordinate and 80 will be behind it. So this particular value of load is 200 kilonewton and this value will be 80 kilonewton. Now guys, by how much distance you have to shift in this direction? 2 meter, so that you will get this particular ordinate. Clear? So what is written over here? 3 by 9. So I will write 9, but 3 minus 2. So it will become 1 by 9. And this is your ordinate. Getting a point? So let's calculate the maximum negative shear force. Maximum negative shear force, which is equal to 200 multiplied by 3 by 9 plus 80 into 1 by 9. Please calculate this value. You will get the answer. So this value is coming around 75.55 kilonewton, and this value is negative shear force, maximum negative shear force. Clear? Very nice. So which option is correct? D. D is the correct answer. D is the correct answer. Very nice, Rishabh. You got the answer already, right? D is the correct answer. Very nice, Swapnil. Very good. Let's move to the next question. Okay. Now this is again a logical question, not a numerical one, because you know that in this particular problem, they didn't write any numerical value, either span or the loads values are not there, right? But still you have to get the value of ILD for member DI. So just you have to apply the logic to get the result. Tell me the correct answer for this. Swapnil D. Okay. Any other student who know the answer? Akash B. Okay. A very simple question, but a logical one. Yatish A, and A is the correct answer. 0 throughout the span. Why it is 0? Why it is 0? Listen carefully. A is the correct answer. Listen carefully. Do you remember this concept when you have three members which is connected at a joint? Three members which is connected at a joint. Let us suppose this force is F1, this force is F2, and this force is F3. And this angle is theta. Okay. Now tell me guys, do you remember this concept when three members are meeting at a joint and these two members are having collinear and opposite forces, or you can say that equal and alike forces basically, right? Equal means same magnitude, alike means same nature, like tension, tension, compression, compression, like this. Then the third member will have zero force. Getting a point, right? I will explain, Akash. Listen carefully. So let us suppose if a unit load is present at this location, then what is the value of force at this particular member? It is 0. Now, if your unit load will present at this location, then again the force in this particular member will be 0. Why it is 0? I will explain. Because if you solve this particular member from joint D, you will get 0 as an answer. Correct? Now let us suppose if unit load is present exactly at I, again you will get 0. Why? There are two possibilities to find out the value of DI member force. Either you can solve joint I or you can solve joint D. So if I want to solve the member DI from joint I, that is very difficult. Why? Because there are 5 members, 1, 2, 3, 4, 5. And it's not possible to get the answer. But if I solve the same member at joint D or from joint D, then I will get the answer as a 0. Why? Because if you solve this particular joint, guys, again the value will remain 0 itself, right? That's why it is 0. Now if your load will shift over here, again you will get 0 force. If load will be here, again it will be 0. If load will be here, again it is 0. If load will be here, again it is 0. That's why A is the correct answer for this particular problem. Akash, it is clear? Akash, it is clear to you? Okay, very nice. Now let's move to the next question. Let's move to the next question. Right? Now again, it is a different type of question. Let's understand how we can do it. Now this question is related to the ILD part. Now what is given to us? If the ratio of area of ILD, that positive area and the negative area for the vertical reaction at D, taking the modulus of each value is 36, modulus of each value is 36, ratio of this particular value, okay, then find out the length of span CD. Let us suppose this particular joint is C and this is D. Now first what you need to do, guys, you need to draw the ILD for reaction at D. Okay, let's do it. For reaction at D, we need to draw the ILD first. Okay, so guys, let us suppose this is our reaction, which is basically VD, and VD is equal to 1 that we have given. That means unit displacement. So the deflected shape of the structure will be like this. Correct? Correct? And this ordinate will be 1. And this is positive. This length is L. This is 4 meter. This is basically 2 meter. And this particular ordinate will be negative, which we have to find. Okay? We don't know right now how much it is because this L is not known to us. That is the problem. Okay, so what we can do, guys, let us consider this ordinate as a y1 and this ordinate as a y2. Let's calculate y1 and y2 first by using similar triangle concept. So can I say that when we have a, let's use a next page. So when we have L length of span, when we have L length of span, then the ordinate is 1. When we have length L plus 4, kindly check L plus 4, then ordinate is y1. So just cross multiply it to get the y1 value, which is L by 4 divided by L. This is y1, clear? Similarly, we have to find out the L2 value. Sorry, y2 value. This is y2. So when we have L span, ordinate is 1 and this distance is 2 meter. So 2 meter, the ordinate is y2. So y2 should be equal to 2 divided by L. So these are the two value which is required. Okay. Now what is the positive area of ILD? What is the positive area? This is the positive area. Let's calculate. Half into ordinate, that is basically y1. So y1 is L plus 4 divided by L multiplied by length. Length is how much? L plus 4. That is area, positive area. Then we have negative area. What is the negative area? Half into 2 into y2. 2 into y2 means this value. Right? Now, as per the question, the ratio of this area is equal to 36. Clear? But you have to take the modulus of it. Modulus means both the values should be positive, or you can take mod of it, right? So L plus 4 divided by L multiplied by L plus 4 divided by 2, this 2, right? And divided by, you can cancel this 2 and this will be 2 by L and it should be equal to 36. Okay. Can we cancel this L and this L easily? Right? Okay. Now what is remaining in this calculation? L plus 4 square divided by 4, it should be equal to 36. So L plus 4 square is equal to 36 into 4. So L plus 4 is equal to how much? 12. That means L is equal to 8 meter. L is equal to 8 meter. Clear? L is equal to 8 meter. Kindly check it. $10.35, how you are getting? Rishabh Pant, how you get 10.35? I think it is coming around 8 meter. Yes, 8 meter is the correct answer. Clear? 8 meter is the correct answer. Akash, got it. Okay. Rishabh, kindly check your answer. Right? I think you're getting a wrong one. Okay, 8. Very nice. Next question is again a logical one. Kindly read the question and let me know the answer. No problem, Rishabh. But don't do these type of mistake in the exam. Be careful, okay? Now, what you need to tell me, guys, a loaded propped cantilever beam is shown in the figure below. Read the following option and identify the wrong boundary condition. You need to tell me which particular boundary condition is wrong. Which boundary condition is wrong? Kindly consider this is x is equal to 0, right? And this is x is equal to L. Okay, tell me which boundary condition is wrong. At x is equal to 0, slope is 0. It is possible. Please write down. Rishabh, A. Very nice. Yes, guys, A is the correct answer. A is the correct answer. Why? Because we know that at x is equal to 0, theta can't be 0, right? Theta can't be 0. That's why A is the correct answer. And this is the wrong boundary condition. Let's check the other one. At x is equal to 0, y is equal to 0. Yes, it is possible. At x is equal to L, dy by dx is equal to 0. Yes, slope is 0. At x is equal to L, y is equal to 0. Yes, it is also possible. That's why A is the correct answer for the question. This is not a MSQ because we need to find out the wrong boundary condition. Wrong, Rishabh. Wrong means this is only the combination which is wrong. Next question related to the slope deflection method. Okay. Now what you need to tell me, guys, you need to find out the rotation theta b. So you know that how to calculate theta b. Why? Because this is a structure in which we have the equation which is already given to us. Just we have to take the summation of moment at a particular joint and it should be equal to 0. That is the procedure. Okay. Tell me, guys. Now a rigid frame ABCD has AB member as a overhang and AB member as a overhang and A is being free. Support C and D are fixed. DB is vertical member and BC is horizontal member. DB is equal to 5 meter, BC is equal to 5 meter. Okay. Now, if the moment equation are given to us, that is DB, BD, BA and BC and CB, then what should be the value of theta B? So you know that, guys, at joint B, we need to calculate summation moment, nothing else. Let us suppose this is the moment which we have M, B, A, M, BD and M, BC. Correct? So we'll write it down. Summation moment at B is equal to 0. That means minus MBA minus MBD minus MBC is equal to 0. So BA is equal to how much? BA is equal to 54. BD is equal to how much? Minus 0.8 EI into theta B. This is BD value. This is BA value. And then we have BC. BC is equal to this. So it is minus 135 plus 1.6 EI into theta B. And it should be equal to 0. Let's calculate the answer. So minus 54 minus 0.8 EI into theta B. Then minus minus will be plus 135 minus 1.6 EI into theta B. So let's calculate what is the value of theta B, guys. 135 minus 54. So it is 81 and it should be equal to 1.6 plus 0.8. So this will be 2.4. You can make it 2.4 EI into theta B. So theta B will be equal to 81 divided by 2.4. 33.75 divided by EI. And the value which we are getting is positive. That means that particular joint is trying to rotate clockwise. The rotation should be clockwise in nature. Clear? It should be clockwise in nature. The rotation is clockwise in nature. Clear? Getting a point? Okay, done. Next question, we have already done it, right? This particular problem we have solved, right? At joint E and at joint F, the slope will change. That's why D is the correct answer. Okay. Now the last question of the session, please tell me guys, now the remaining 15 questions you have to solve. I will show you the questions also, right? But tell me for this particular problem, what will be the answer? The following statement are made regarding the force method of structure analysis. Read the statement and choose the correct option. Statement P. In the force method, compatible equations are written for the force and moment equilibrium. The slope deflection method is a force method. Which statement is wrong? Tell me guys. In this method, compatible equations are written for force and moment equilibrium. B. Statement P is true but Q is false. We know that guys, slope deflection method is not a force method, it is a displacement method. Hence Q is wrong, right? Q is wrong. Q is wrong, right? Now tell me, what about A statement, P statement? In this method, compatible equations are written, yes, definitely, for the force and moment equilibrium. B, yes. Yes, definitely we are trying to write the compatible equation for the force and moment equilibrium condition, right? So that's why B is the correct answer for the problem. Crystal clear? Okay, very well. So guys, thank you so much. But let me tell you something over here. We have another 15 question which will be as a homework as per our series. So kindly solve these questions. Up to 30 number of questions you have, right? So kindly solve these questions, and where you will get this particular PDF, let me share you the link in my chat box. Okay, kindly join that Telegram. In upcoming days, whatever session will be there guys, you will get the link of that particular session also, as well as the PDF of this particular class. Okay, kindly join this particular Telegram. I am sharing the link in my in our chat box. Oh, okay, done. Kindly check it guys. Kindly join this particular Telegram group. Okay, okay. Okay guys, so thank you so much for joining the session, and kindly download our application also, right? So that you can have some app free session in which you will get some question practice session, revision questions and etc, right? So thank you so much. So reaction for the frame structure daily dose play. Okay, I will plan it, Ratish. Okay, I will plan it. Okay, thank you so much guys, and let's close it and let's meet in the next one. Bye bye, take care, thank you so much. I hope you have enjoyed today.